Okay, hi, Math 2504. And thank you for those that made it in person, and thank you for those that are in Zoom. We just need to also see you.
Oh, yeah. I will come over here.
All right, so that's me, but I'm less important here. So here's Mehta. She'll be speaking in a sec. We've just changed room. Physically, we changed room because there were no lights in the other room. Understand from people in the lecture. Who was here in the lecture yesterday physically? And then it got dark. So it was kind of okay, exciting. Well, something more exciting tonight. You've got Dr. Mehta, a friend and a longtime collaborator in the School of Math and Physics. Mehta has a PhD from School of Math and Physics from a period that was maybe near Y2K or something like that.
Yep.
You'll hear about that. And she is an industry professional in many fields with notable focus on transport. And I'm sure you'll hear about that. Mehta has been doing internships with the School of Math and Physics for years. So it's often the case that people do this course and then engage with Mehta, do an internship. Sometimes yes, sometimes no, but great that you came along. So I'm sure that will be questions both for the people here and people online, and those on YouTube. I hope you enjoyed the lecture as well. So thanks a lot, Mehta, for coming. Let's give Mehta a round of applause. All yours.
So, hello, everyone. Thank you for venturing out in the rain. I went to leave and the storm came down and I walked here. So I'm a bit kind of, but mathematicians are problem solvers. So I made my way here anyway through the driving rain. So just a little outline of what I'm going to talk to you guys about today. I'm going to give you a little bit of background on me. Oh, I've lost the Zoom chat. I don't know how.
Oh, the chat event.
Yeah. Technology. Yeah, sometimes our friend, sometimes our enemy. Okay. And yeah, jump in with questions whenever you have them. You don't have to wait till the end. You can if you want to, but if I say something and you're like, oh, I'd like to hear more about that, this is supposed to be about giving you guys some idea of what it's like to do your degree and then to go out into the workforce. So if there's stuff that I touch on that you want to hear more about, just give me a yell. And on Zoom as well, just pop a message in the chat. So I'll start by telling you a little bit about my background, how I ended up in industry, and then sort of how my career has evolved over the years. I'll tell you a little bit about each workplace and what I liked and didn't like about each place. I'm a software engineer, so I'll tell you a little bit about what it's like to be a software engineer and kind of where it links up with what I did at university and where it doesn't. And then I'll talk a little bit about employee attributes, just in terms of, down the track, if you're looking to get work in industry or if you're looking to do things. So, Yoni and I often collaborate on things. It helps to kind of understand how industry works if you want to do those sorts of things, whether from within a university or within industry. So my origin story, hang on. Should I just leave it like this so I can see the chat box? Because every time I click to go to the thing, I lose it. Oh, okay. All right. Oh, okay. Okay. Where's the Zoom gone?
Yeah, sorry, Chad. This is room change and everything breaks down. Complicated.
Yeah, the Zoom.
Especially since
There it is.
You see a share?
Yeah.
And we'll just share the.
Yeah. And then I'll just start it again if you're monitoring the window.
Yeah.
Now where's the. Will that do it? No.
Yeah. Oh, I see. You want full
Yeah.
screen. Sorry. What did I do now?
Oh. The screen share stopped.
Two drivers.
Okay. And then let's go back here.
Yes, class, we are good with computers.
I usually use Teams, so, and everything's in a slightly different spot.
Okay.
Okay, so hopefully you guys can all see it now. And when I click on, you can still see them. Excellent. All right, so starting off with how I ended up in maths. So basically, I have a bit of a family history of mathematics. My dad did an economics PhD and then went on to do a maths PhD because, you know, you need 2 PhDs, of course. And my uncle also had a maths PhD. So when I was really, really little and I was learning to read, my uncle used to teach me how to read English on his vector calculus textbooks and his algebra. He was an algebraic geometer, and he used to teach me how to read on his algebraic geometry textbooks. I still have trouble saying it. So, you know, you can imagine when I was 3, I really struggled. And when people used to ask me what I wanted to be when I grew up, I used to say, I want to be a professor in algebra and topology. So, you know, I was very indoctrinated into the maths tradition from a really young age. And then my mother studied maths as well. So she actually did her, she finished her undergraduate degree while I was doing mine, and we were in lectures together, which was kind of fun, especially when I needed notes from someone. So yeah, I kind of just grew up always being surrounded by maths. My dad taught me how to do probability when I was around 6. So I had a bit of an advantage there going into school. I already knew how to do quite a lot of stuff. And I used to kind of get told stories about things like the Mobius strip and all of the kind of more interesting, deep mathematical concepts that most people don't get exposed to until much later on. So I did a degree in maths, and I was kind of planning to keep going and become an academic. And I had like a PhD scholarship, and I was coming to the end of the PhD scholarship, but I hadn't finished my PhD. And a friend of mine rang me up, also a maths person, and she said she'd heard of this job going at a company called Opcom. Would I be interested? So I went in for the interview. I had never actually used computers before. So when I went through my maths degree, I didn't like computers. I didn't really understand the point of them, and I didn't really understand the point of programming. And I did do like computer science in my degree, but I refused to go to the labs, and I wrote out my exams by hand. And somehow managed to pass anyway. So big mistake on my part. Really wish I had actually done the computer labs, because when I started at this job as a software tester, I walked in, I didn't know how to switch the computer on, can you believe? We'd only used like dumb terminals in the maths department, and they were just kind of always on. And I walked in, I was like, ooh, how do you turn on a PC? And had to pretend that I knew how to do everything, because you know, you don't want to look like a complete idiot on your first day at work. But because of all of the problem solving skills I'd used through my maths degree and through my PhD, I picked it up super quick. And after about 6 months of being a software tester, my boss approached me and said, I think you'd make a really good C++ programmer. And they sent me on a 1-week course to learn C++, and then I became a C++ programmer after that. So that's kind of how I ended up in software engineering. The company did journey planning. So basically similar to what Google Maps does, but with a focus on ticketing for the UK. And in the UK, they've got this really complicated system of rules. They all break lots of mathematical rules. So for example, the triangle inequality, if you go from A to B and B to C, the fare is not necessarily more expensive, or sometimes it's cheaper to do that than to go directly from A to C. So we had to kind of come up with new ways to solve those problems. You know, there's loads of optimization-ish kind of problems to solve in journey planning. I was there for a really long time. So the company started off as Opcom, turned into Carmen Systems. It was bought by Carmen Systems, bought by Jeppesen, which is a Boeing subsidiary. And then finally it was bought by Silverell. So I was there for like 20 years through different kind of incarnations, had 2 kids through the time, worked part-time. I think in the entire time I was there, I worked full-time for 2 years out of 20. All the other time I worked part-time, and they were very happy for me to do that because I had such a unique skill set to bring to the company. From there, I went to a company called Deswick that does mining optimization. So it does schedule, and I was working on the tool that did scheduling for the mine sites, like work out when they're going to explode things and when they're going to drive trucks in and drive trucks out. And I was there for about a year, and then I ended up at a company called Do Smart Thing, which is where I am now. So that's journey planning again, but with a focus on major events and trying to reduce carbon footprint for those major events. So kind of optimizing entire networks rather than how I travel or how you travel. It's looking at making sure all of us can travel pretty nicely, get there pretty much on time, and hopefully catch a bus or a train or walk rather than driving everywhere, which is the other reason I walked here today, because I try and literally walk the walk, and not just tell everyone else they should catch public transport. So I've kind of covered bits of this slide. Oh, yep. Maybe over there. There's not much over there. Oh, yeah. Okay.
But then it doesn't show you, and that's okay. But we know, I see.
Okay. So I've told you how I ended up working at Opcom. So in my time there, I started as a tester, and then they moved me into software engineering. I also did some support management work, which I found really useful because one thing, so doing a maths degree is great for your problem solving techniques, but it doesn't necessarily give you a lot of exposure to what like real people who don't really understand technology want. So working directly with the customers and them saying, oh, why can't I get this journey? Why do you give me this journey? I want this journey. And I'm like, well, it's 3 minutes longer. And they're like, but it's better. Why is it better? You have to define that mathematically for me to be able to code it. And often they can't do that. And being able to talk to them directly and work that out is really helpful. Because as mathematicians, we want to come up with perfect solutions, but often real life doesn't really work that way. I don't know if any of you guys kind of have experienced this with the public transport network in Brisbane, for example. But, you know, like so coming here today, I live in Taringa, which is really not that far. And Google Maps told me to catch 2 buses to get here. I'm like, why would I do that? And it would save me 4 minutes from walking. So, and I have to walk up and down hills, whereas if I just walk 50 minutes, no hills, get here fine. Ignore the storm for the purposes of this. But yeah, so human beings prefer those journeys, but how do you tell a mathematical program that, no, pick me the longer one, please. Pick me the one that's longer with more walking. It's not that obvious. Learning to code was kind of interesting, especially since I guess I came to it with a bit of resistance. What I did find is once I was actually solving problems that couldn't be solved, it was a lot like by hand. That's where it kind of got more exciting. So what I found a little bit frustrating about learning to code when I was at university is just like anything else, you know, like when you learn maths in grade 1 and 2 and 3, they're teaching you a lot of stuff that is sort of obvious, and you're kind of, you know, why do I really need to learn to add? I've got a calculator. Why do I really need to learn to long divide? I've got a calculator. I mean, I loved all of that stuff because I loved all the techniques it showed. But when I did software engineering at uni, I was like, why do I have to learn to write a sort algorithm? There's 100 libraries that do sorts. Why would I need to rewrite it? Once I actually got into the workforce, it was like, oh, like there is no library that's going to do what I want to do. And if I code it up, it'll work really well. The company was kind of medium sized. So there were 40 people in Brisbane, but then as it kind of was bought by other entities, it always stayed between the 20 to 40 people size in Brisbane, but sometimes there'd be like 100 people in Sweden or 10 people in England, or, you know, just all over the place. So then that kind of presents different challenges again, because not only are you communicating complex technical details to people who don't have a technical background, don't have a mathematical background, but you're also trying to do that across time zones and across multiple time zones. So in that particular company, I ended up needing to code in C++, C#, Java, Python, and Perl, and React. So lots of different languages. So I wouldn't worry too much about what language you learn now. The language is not the kind of pivotal bit, because it's the language techniques. So you can translate the language techniques you're learning in Julia or in any other courses you're doing where you might be learning some Java here and there. It translates really well to other languages once you get the basics of, you know, writing if statements and for loops and all of that kind of thing. Once you have the algorithmic kind of understanding of what makes code good and what makes code fast, you can translate. Some weeks I had to write in all of those languages in 1 week, which was a little confusing, but you kind of manage. And then the other technologies are all kind of cloud-based technologies. And there's countless more, actually.
Mehta, I have one question there.
Yes.
Maybe others have other. What's Redis?
Redis is a database, so it's a non-structured database, no SQL. So it's a document-based database. It's super fast to read and to write. So SQL databases, which is what most people used at uni, I think, and most people use in general, they're very fast to look up things, but they're not very fast to write to. So if you are writing software where you need to store lots of data and you need to do it in real time, store it and then do something else, you want a NoSQL database. So, yeah. So Deswick. So I started working at Deswick because I had worked with someone previously. So and they had said to their boss, oh, you know, we should see if Mehta wants to join the team. She'd be really good. She knows how to do this kind of stuff. And they approached me and asked me to come in for an interview, which I did. And then I said no. And then they asked me again 2 years later, and I said no again. And then 5 years later, I went and joined them. So it was kind of, I guess, that's one of those stories where networks are really important. So the people you are meeting now, the people you are getting lectures from now, if you go to any other industry events, if you meet people who are, you know, from different companies, get their details, get on their LinkedIns. It's a really, really good way of getting jobs, opportunities, internships, all of those sorts of things. Because if you're going through recruiters and the general recruitment process, that can work, but then you're just in a sea of lots of other people. Whereas if you've met someone at an industry event and you like the sound of what they've done, or you've met someone through an internship you've done, like another student or whatever, and they get a job somewhere, or they start working at a university somewhere or whatever, that's where you get some really kind of interesting collaboration potential going on. I was there as a senior software engineer, and after a couple of months, they moved me onto a scoping project, which was a 6-month project to ostensibly write a lot of documents, but I decided not to do it that way. I will tell you that story in a minute. That's a really big company with an international presence. It's really successful. And they do lots of very interesting deep maths optimization. Their technologies are C#. They use a lot of WinForms, which is kind of very old school. It's installed software that you can only use on PCs. And they use for front-end stuff, they use Vue and they use SQLite for their database. And then I ended up at USmartThing. So this is a UK-based company. And again, I got that job because someone I worked with at Silverell works there. So they were fully in the UK, and then COVID hit. And I had said to him when they were in the UK, if you ever want anyone in Brisbane, hit me up. And they were like, no, we don't want anyone working remote. And then COVID hit and everyone was working remote. And he rang me up and he said, are you still keen to work for us? And I was like, absolutely, yes. So I went to work for them. and I'm the lead of software engineering and innovation there. So it's a really small company. There's 5 engineers, 2 in Turkey, 1 in England, and 3 in Brisbane, including me. We use C#, React, MongoDB, which is another database. It's similar to Redis, so it's not an SQL database, and Docker and Gravity, which are all, Docker is a containerization software, Gravity is an authentication suite to make your sites secure. Oh, I'm right-clicking. I also always use a Mac, so. So just to go through some of the problems, I'll start with the ones in mining. So mining has been traditionally disconnected because people are using the software down deep in a mine. There's no internet, there's no connectivity. They need to, they might have someone in a mine in several locations in South America, say, but they need to coordinate between those locations because they might be using the same trucks, but they have no way of communicating with each other. So traditionally, web technologies haven't been used in that industry. So a lot of mining software companies these days will kind of try and attract software engineers to do legacy projects, which is basically where they're moving software over from a very old legacy system. Nobody really knows how it works. Nobody is left at the company that knew how it worked because it was written 20, 30, maybe even 40 years ago. And they're trying to translate it into cloud-based technologies and new web-based technologies. And so the scheduling optimization that they use and the optimization that they use, very heuristic based, and very small changes in the initial conditions can lead to massive changes in the final schedule. And that because they're such a successful business, they have a very low tolerance for change. So you would make what seemed to be a really good change. So you'd look at the code and you'd look at the maths and you'd go, well, that's not right. I'll change this, or I'll change this factor. And then all of a sudden the schedule's completely different for a particular mine. And the customer's like, no, you have to roll that back. We can't be dealing with that because they can't have their schedules change that massively from day to day. So that presents a big challenge, because if you go in and you find an issue, you probably can't fix it, or at least not for that particular customer. You might be able to for a subsequent customer. So when I was at Deswick, they didn't have any web-based technologies in the scheduling software. And they put me on this scoping study, and I was like, really wanted to use web-based technologies because WinForms is painful, it's hard to use, not very, the user, it's not very easy or intuitive to use. So I was like really keen to convince them to, use this newfangled thing called the internet. And so I just did so one of the things that I think is kind of really useful, and I think that it's the way that researchers generally work, is you don't tell, you show. So rather than just saying, I'm right, you're wrong, I kind of went and I made them a little web app and said, look, this is how you can do what you need to do. Think about it. And they did end up adopting it. So it's just something to kind of take into account. I mean, even while you're doing your degrees, like if you're doing any kind of research project or internship, try stuff. If you're not sure, you're better off making a decision, trying something, it being wrong, and then you starting again and trying something different than just like arguing with yourself about it or arguing with your teammate or whatever. So then in the transport industry, which is where I am now and where I was before mining, there's loads of problems. They kind of have not changed that much over the last 10 years because they're really difficult to solve. So you guys have probably heard of some of the journey planning algorithms. Yes, no, maybe? Hasn't, not in this course, but just in general, have any of you heard of any kind of algorithms used for journey planning? Sort of, traveling salesman, maybe? Dijkstra's algorithm. So Dijkstra's algorithm is still really, really widely used, or at least it underpins a lot of journey planners. The problem with the problem with all of the algorithms really is that the data sets are massive. So, you know, Brisbane's not a big deal, but if you're looking at the UK, for example, it's got like a train network that spans the entire country, and then the country is split up into 11 little subdivisions, each of which have trams, buses. There's a hovercraft to Eton in the data. That's a fun one. I don't know if you can actually catch it, but so it's hard to run the algorithms quickly on that data set. So you've got to like really optimize a lot. There's a lot of real-time data available and everyone wants that shown. So, you know, you've probably all been standing at a bus stop waiting and watching the little dot move very slowly closer to you. That needs to, you know, that's quite hard to incorporate into a dynamic algorithm and not have it take ages to come back. And nobody's going to wait ages for a journey plan to come back. I've alluded to the different cost functions earlier. So usually journey planners just find you the fastest way to get there. And that's not necessarily what you want to do. Like in the UK, if you travel from one end of the UK to the other, the fastest way might be to take 11 separate train trips. Nobody's going to do that. Like, so what is the point of even returning that? So that's kind of, so trying to work in a different cost function to maybe do like 3 train legs or something different that might take half an hour longer, but honestly, who cares? The ticketing rules that I mentioned before, the UK events space and the international events space, less so in Australia, sadly, but in Europe, they're very, very focused on reducing emissions. All major events like the Olympics and the Commonwealth Games have a commitment to be net zero, which means that giving good, accurate information on public transport travel is really important, because if you can see how to get there, you'll use it. I just came back from a European trip and I was in Venice and I was trying to work out how to get from the airport to my hotel, and it, like, Google Maps didn't have the data. So it didn't actually tell me how to get to my hotel. I had to find out from my boss who just happens to know. He seems to know like all the timetables all over the world. He's just like a transport nerd. So yeah, having good information is key. And then customized journey plans, customized travel planning. So saying, you know, I'm actually, you know, I have a hurt foot or I'm in a wheelchair, I can't walk, you know, you need to give me accessible options, or I love walking, please like let me walk more and get the train less. The data is often really dirty as well. So you'll have like lots of places with all the same name, and you've probably noticed it when you've used Google that I don't know if you've ever tried to go to the airport, it's actually quite hard to find Brisbane Airport. It's getting better. It's better this time. Last time I tried to find it, it wouldn't find one of the terminals. So that's just, you know, missing data. Even getting here today, it told me to walk through a building. So some of the fun things I've done at work, hackathons. I got to stay up all night in a warehouse in Berlin with some other people and work on problems to try and win some competition. That was kind of fun. I lodged a patent on optimizing large data sets. So that was the UK data, like trying to work out how to traverse that data quickly rather than returning the journey plan in 2 minutes. Some of the graphic stuff that I got to do at the mining company at Deswick were really cool. So there's some really low-level graphics stuff, and the mathematics around that is very fascinating. Congestion management. So increasingly stations and buses and stuff have sensors so that you can say, oh, this station's really crowded, maybe start telling people to go a different way. So being able to feed that data into the system in real time is quite fun. Exploring new algorithms, trying to work out how Google do their journey planning. That's something I like to do quite a bit. And then we did some software for the Commonwealth Games in 2022, which was really interesting and super stressful. It was held in Birmingham and it was committed to be net zero. And so they had all these special shuttle buses that they put on that weren't available through Google, which were available through our system. And then 2 weeks before the games, so they didn't have any parking areas and no parking information. 2 weeks before the games, the rail industry announced a strike on the day of the opening ceremony. So we had to write a journey planner to use this coach data that they found. They're like, here, put this coach data into your system now. So we did that. That was fun in a like super stressful, didn't sleep for 2 weeks kind of way.
So the change of room was fun.
The sorry?
A change of room to my room is...
Yeah, exactly. Yeah. So a few of you had heard of Dijkstra. So Dijkstra actually kind of plays quite well with some other algorithms. So one of those is A*, which is basically where you kind of direct the search based on what's closer and further away. Raptor, so I don't know if any of you have heard, there's an open source journey planner. You can download the code. It's written in Java. It's called Open Trip Planner, and that uses the Raptor algorithm, which is, it's a round-based algorithm. So basically, it just goes around and around and around and then finds you the best path by kind of analyzing each node. CSA, connection scan algorithm, it's really fast. It basically takes all of the data, all of the trip and stop data into memory and pre-processes all the connections between everything, hence the name connection scan algorithm. It's very fast, but you can't change it quickly. So if you get real-time data, you can't sort of alter that algorithm to make that work. Transfer patterns may be one of the things that Google uses. I'm not sure. We're not sure, we think. They certainly released a paper on it, and that transfer patterns is about international blended travel. So, you know, you've got like an international layer of a network. You've got a national layer of a network. So the international layer may be like flights from London to Paris or London to Rome. The national layer might be the UK trains. And then the local layer is the walking between stops, the walking to people's houses, trams, buses, that kind of thing. So it kind of, the idea behind transfer patterns very, very roughly is it kind of, you start on the layer you're at, so maybe at your house, so you're on the local layer. And then as soon as you can get onto the next layer, you get onto the next layer and so on. So you try and get to the kind of sparser layer as quickly as possible and then come back down to the local layer. It's pretty cool. But with all of these, we have to balance the need for speed, like the fact that people just leave a web page if it hasn't returned. And I think it's 50 milliseconds or something ridiculous. It's really low. So this is one of the things you learn as a software engineer, that if you can't return the answer super quick, you've lost your audience. They've gone somewhere else. So just a quick kind of rundown of what I actually do every day. So for a very, very long time, software engineers use agile methodologies. So it's agile methodologies is just kind of a way of describing a process. So I remember when I first heard about all of this stuff, it kind of gave me the giggles, because the basic tenet of, the most popular agile methodology at the moment is called Scrum. And Scrum involves daily stand-up meetings where you and your team stand around in a circle and kind of take turns to say what you did that day. And you're supposed to stand so it doesn't go for as long, because if you were sitting down, you waffle. And you run it in things called sprints. So your sprints are around 2 weeks, but they can be 1 week, 2 weeks, 3 weeks, 4 weeks. I think Octopus Deploy do 8-week sprints, which is very strange. But there's all these kind of rituals around it that you need to follow. And it's just to give the team some structure and the communication between team members some structure. It's probably quite different now, but I remember when I was doing my honours and my PhD, the whole kind of communication piece at uni was quite chaotic. Probably partly because I'm a bit chaotic as well. But, you know, it's so moving into industry, it's very, you have to do things a particular way at a particular time. So every day I will spend some of my day writing my own code, designing my own code, helping other people design their code, reviewing other people's code. So I spend a ridiculous amount of time reading code. And then you need to test your own code and sometimes other people's code. We also it's very kind of, most software companies want people to be what's called full stack. So it used to be that you'd go into a software engineering company. So certainly when I started software engineering, I just wrote back-end code. I wrote the stuff that interacted with the database and the data and did all the heavy going algorithmic work. But these days, most engineers have to do a little bit of everything. So they have to do a little bit of the front-end work, some of the back-end work. They have to be able to automate the deployments and the tests and deploy to cloud, assuming you're using a cloud architecture. So it's a very varied kind of skill set that you have to cultivate. This is just a picture of our software. Some of the things that we have to try and incorporate. So like tickets in the UK, you can get like ticket prices depending on how many adults and children are traveling, and it's not necessarily 2 times the adult price and 3 times the kids price. There's family tickets and all sorts of things like that. You can ask for step-free travel, so you can ask to not have to go upstairs in your walks and that kind of thing, or like ask for travel that allows you to take your bus on board. And that's all in the data to a varying degree. Electric vehicles, kind of a newer type of problem that's come up in journey planning. So because the chargers aren't as readily available as they might have been, they're getting more and more accessible now, but it's important to like offer people journey plans where they can actually stop and charge their vehicle. So there's places where you can get, most countries will have feeds for the EV charging points. They're quite expensive, unfortunately. And then you can also, some of the infrastructure will theoretically allow you to book the charge point in advance. So you can say, oh, I'm leaving home, I'm driving to Sydney, and I want to book that charging point in 5 hours. So trying to incorporate that into our journey plan. And for it to say, oh, actually, that charge point's already booked, you can't go there, so go this other way. In reality, the infrastructure is pretty bad at the moment, so you can't actually do any of that stuff, but someday you hopefully will be able to, like someday very soon. So I guess some of these things are kind of eternally useful in software engineering and other industries, but some of these things are definitely big time hot topics. The top one is one. So if I had $1 for every time my boss had asked me in the last 6 months to put AI into the software, I'd be very rich, very rich. So, and the data science question has been happening for a little while, that companies will hire data scientists and say, here, take this data and do something. And these poor students, honestly, it's horrific to watch. They say, what do you want me to find out? I don't know, just something interesting, just find something interesting. And I've literally heard that said on numerous occasions. So if you can work out what they want, you will be in the money, honestly.
Project 3, which will be the students' next and final endeavor, is of that nature, kind of not fully defined questions with data.
Yeah.
So that's okay, right?
It's okay, but it's hard. And especially in like, you know, like when I was at Silver Owl, we hired a data science graduate and they'd never worked in the industry before, never. Didn't get trained, just got given a database. Do something. So, you know.
Project 3 won't be so hard, but prep for hard work like that in industry. That's what it seems like. Okay.
Yeah. But which is where I think with stuff like that, like if you do ever get put in that position, find out what the customers want, and that will really help you. Because if you can kind of, if you can look at what people are complaining about and then go, oh, actually, that would be, you know, that would be a good thing to use AI to solve, or that would be a good thing to use data science to solve. That makes you very valuable, very, very valuable. I guess the other thing, so the way you think. So are you a linear thinker? Are you a lateral thinker? You do a lot of kind of independent work when you're at university. So you do some group work, but a lot of what you do when you study is by yourself. You don't have to justify your reasoning to yourself. So one thing I used to find a lot, I am a lateral thinker and I jump around, like my brain kind of jumps around like a flea, and I don't necessarily know how I've come to, like, I can work it out eventually, but I don't always know why I think something's going to work. So I'll have an idea and I'll be pretty certain it's going to work. And I'm pretty like if I think something's going to work, it works. I don't think that off, like, it's not like I'm walking around knowing everything, but when I think I know something, I usually know it. But if someone comes along and goes, what was your reasoning behind that? I'm like, and it took me a long time to work that out. So that's something to kind of sit back and remember, that if you're working in a team, the way you solve problems and the way they solve problems might be very different. And you might need to communicate your solutions to people who are just not following how you got there. So that's a really valuable skill to kind of cultivate. Is Julia object-oriented? I'm sure I ask you this every year.
It's not object-oriented in the classic sense, but it has patterns that are similar. So it is functions with their methods that act on objects,
Yeah.
but classes or types do not have methods in them.
Okay.
But it's the same type of functionality is achieved with a slightly different view via multiple dispatch.
Yep. So object-oriented coding, generally, I think most software companies use it now, and it is a very different way of structuring things. So when I first started working at Silver Ale, it was like there was a kind of running joke, writing code like a mathematician, which was basically just line after line after line, spaghetti code. So you hadn't turned it into objects and classes and actually making them interact with each other in the way that software engineers would traditionally like it to be done. So if you have the opportunity to learn some of those, I mean, it sounds like you can learn those concepts definitely in Julia, but that's something to kind of keep in mind if you end up doing more coding down the track.
Yeah, I mean the concept that students learned of types and type hierarchies, etc. That's kind of the nature of object oriented, and then a type can behave, a subtype can behave differently.
Yeah.
So polymorphism, those patterns exist. There's
so they're quite important in general in the industry. Writing code that other people can understand. So I guess that's the other thing, that if you're only writing code for yourself, you don't really bother doing it. I know I certainly, when I did my PhD thesis, massive mistake. I was a big fan of the TV show Buffy, the Vampire Slayer, and I decided that it would be a really good idea to call my equations after characters from the show, which was fine at the time. But then later on, I went to go and change them, and I'm like, what is Xander? Which equation is that? So don't do that. Learn from my mistakes. Write code that someone else could understand, because if you only write code you can understand, then in 3 weeks' time, you won't understand it either. Transferable skills. So any kind of academic pursuits, so everything you're doing now, anything you do at uni from now on, it's all very transferable. So I've never directly used my PhD at my work, because my PhD was in quantum superalgebras, so not something that is that useful in journey planning directly, but indirectly it's been really useful to me, because just the kind of the perseverance, the problem solving, the kind of, oh, I can't solve this way, let me try this way, is invaluable. It has been invaluable to me. Collaboration, I mean, this is a recurring theme. And it's something I think you do group work at university, but it's with different people all the time. And when you go into industry, you'll be working with the same people by and large for a long time. If you go into industry, or if you go into academia, you'll be working with the same people all the time by and large. And you might not like some of them, and you might really like some of them. And it's just it's a real skill to be able to collaborate with all of those people. I have to remind myself of the next one almost every day. There's more than one correct in code styling. I have a way I like things to be done, but that, you know, I might like to call things a particular way and you might like to call things a different way. As long as they both meet the agreed upon standard of the company, let it go. And then, yeah, teamwork. So if you get the opportunity to do internships and other kind of collaborations through your degree, take them. It's an awesome thing to do. And that's it. I actually didn't know if that was the last stuff.
On that note, no, that's good because first of all, let's thank Mehta. Give her a big round of applause. Thank you, Mehta. And there's some time for questions, and I'm sure there are some. First question is how to get the Zoom going. I don't know, but I got it there. So we see you. So
I've got the.
So
Yeah.
In Julia, you can put emojis in function and variable names. Should you do this?
If they really mean something, yes. So if you were writing an animated character and you were telling it, make me smile, sure, put an emoji there.
But there was a homework submission where some very creative student put all of the code was emojis, like for a whole function. And it was actually beautiful.
That is
I don't know if
cool.
that student's here. That was you. Well done. No, yeah, no, that won't pass the industry test, but that was good.
You were talking about like refactoring spaghetti code that was written for mathematicians or by mathematicians.
Yeah.
How much time do you think you spend like comparatively designing like an algorithm versus structuring it in a way which is like nice?
So the kind of agile methodology works really well for my brain. So what I tend to do is I just get the algorithm down. I don't worry about the structure to start off with. I just get it all written. If it's spaghetti code, it's spaghetti code. And then I would probably spend, it's probably double the time of actually getting the algorithm down if it's complex. If it's a simple algorithm, often it's just right the first time. But if it's reasonably complex, I then go through, I look for anything that's kind of duplicated, and I go, okay, well, that might make sense to make that into an object or a class, and I could go from there.
What from your maths background did you find helpful in?
Interestingly, probably combinatorics and graph theory and networks. So the company, but all the companies I've worked for have had quite a bit of optimization and heuristic stuff in their code. But what tends to happen with those areas is that it gets written and then you don't have to write it again. So I haven't used a lot of my optimization just because by the time I turned up at those companies, the optimization software had been written. But I've used heaps and heaps of graph theory type techniques.
Question at home, did you do any internships during your degree? Those were different times. But...
They were different times. I don't know if there were any. I don't recall. I never knew of any. I was a bit of a.
Let's use it for your experience as a mentor of internship. Let's use a question for you as a mentor of internship students from here.
We've in various companies that I've been in, we've had interns from UQ and QT, mostly UQ, and it's been incredible. So the standard of interns that come out of the UQ Maths department is actually incredibly high. So well done, all of you already. And we've usually, we've gotten them to do all sorts of different internships, writing new algorithms. So I think one of the people who did an internship with us wrote I think they wrote a connection scan algorithm for us, like they coded it up. Someone else has done some 3D modeling of journey plans, like with actual altitude and stuff. and through buildings and hills and that kind of thing. So it's a good thing to do. Yeah. And you often get offered a job at the end, so.
Anyone?
What industry did you like the most out of all the industries that you've worked in?
The one that I'm in now, it's real. I find it, so, I mean, mining is a very lucrative industry, and journey planning isn't really. It's not lucrative. It's kind of middle of the road, but mining often gets a lot of money thrown at it by the government, and other sources. But I love the problems that they have in the journey planning space. And I love kind of the diversity of problems. So, you know, every couple of weeks I'm working on something completely different. I just finished doing a project writing our own autocomplete for like apps. And, now I'm doing something to do with like hybrid travel with driving trains and cycling and stuff. So I love that kind of diversity of problem.
What do you think about the new trend of seemingly arbitrarily integrating AI into every piece of software?
I think it's weird. So one of the things I have been asked is, look, AI can make this graph. I give AI this data and it makes this graph. And I'm kind of like, Excel's been able to do that for about 20 years. So I think it's one of those things where it has the potential to be really powerful, but everyone's trying to use it for the wrong thing. So it's a difficult one. I'm just glad that we're past the, do you think you can use Bitcoin in your software trend? That was more annoying. No, I don't think we can. At least, I mean, AI, I think there's, especially given in journey planning, there's user preferences involved. I think AI can be very powerful for that sort of thing. Like if you can crowdsource data and use AI to determine trends and things like that, I can see there's a lot of potential there.
So a follow up on that is, the new trend of GitHub Copilot using ChatGPT as your right hand helper, do you use AI a lot for coding?
We do at work. We use Copilot to take meeting notes, which is sometimes helpful, often hilarious. We have a lot of different accents in our team, and some of the versions of what people have said has been quite entertaining. But I mean, I think that things like that are great. Like using AI for stuff like that is really good because, the dream is to get AI to do all the boring stuff, and then we can focus on the more interesting stuff. Like if we can get AI to the stage where I can say, write this algorithm into code for me, that's great. More time for me to nap. But yeah, at the moment, working out what the question is always the difficult thing. So.
Thanks. Are there any more questions or thoughts? Okay, I'll look at home now. So first of all, thanks to those that came here tonight on a rainy night in the penultimate week of semester. I hope you found it worthwhile. I'm actually sure you did. And a huge thank you to Mehta. This is her 4th year. In one of the years, the Queen passed away. So we had to kind of make a swap.
And I did have COVID one year.
You had COVID one year. Okay. But this is still the 4th year of Mehta in the course. And please are you happy for students to connect to you on LinkedIn?
Absolutely. Please do.
Or other means? Yes. So let's give a big round of applause to Mehta, and thank you.
Thanks, everyone.
Okay.